Yeah, welcome back. In this class, we are going to talk about the Cmos Lambda based design rules. These are very important for your external point of view. Okay, here they are going to ask about Cmos Lambda based design rules. Don't forget, even though this question appears in your external point of view, first of all, you have to talk about rules for wires. Okay, then after that, rules for contacts and rules for transistors. But very important point is, wherever there is an implant, that point you should not talk about in Cmos. Why? Because in Cmos we are having only an enhancement mode transistors. We do not have any depletion mode transistor. Along with this, you should talk about some other rules of Cmos which are essential in its design. We will look out those rules with its pictorial representation. Okay, now you may observe this figure. Okay, this one you may observe very clearly. In this figure, if you observe that you are having a P mask and you are having a P well. Is it clear? This is a P well, this is a P mask, and what they are talking about, you can observe very clearly. They are talking about the minimum separation between contact area, this one, I'm talking about this one. The minimum separation between contact area and P mask is what? 2 lambda. And similarly, the minimum separation between P mask and P well, this one, what is it? 1 lambda. And the minimum separation between contact area and P well is equals to what? 3 lambda. Okay, and a very important point you have to note here is the separation between mask and well is 1 lambda. The separation between mask and contact area is 2 lambda, and the separation between contact area and well is 3 lambda. Okay, and you can observe very clearly here if you are having a P diffusion, it is surrounded by what? P mask. This one you can observe, this one. Okay, that is an important point you have to note here also. If you are having a P diffusion, it should be surrounded by P mask. Is it clear? That means you can observe how many rules we have seen here. The separation between contact area and mask, the separation between contact area and well, and the separation between mask and well. 3 rules we have seen. And coming back to this figure, you can observe this figure very clearly. Okay, if you are having two wells, let us consider the separation between these two wells are S. Okay, now you can observe very importantly, you can observe this point very importantly, this one, what S is equals to. Can anybody try to tell? Yeah, S is equals to separation between two wells. That is no doubt here. S is equals to separation between two wells. You do not have any doubt. But very importantly, you can talk about if the two wells are with same potential. What is meant by same potential? Can anybody try to tell? Here. What is meant by same potential? Yeah, absolutely. Yeah, if two wells belongs to let us assume that the two wells are N wells. Here, these two wells, that is nothing but the same potential. If one is N well and another one is P well, that is what? Different potential. That means if two wells are same potential or if two wells are different potential, then you can observe that there is a variation in the separation. If same potential, you can talk about 2 lambda is the minimum separation. If different potential, 6 lambda is the minimum separation. Is it understood? This is rule number 4, rule number 5. Okay, here you have seen with this figure 3 rules. Here you can observe the 2 other rules. Is it clear? And one more rule here itself, you can observe that the separation between well and any diffusion. Here you can talk about this one. The separation between well and any diffusion you can talk about. What is the minimum separation required here? Absolutely. Is it clear? What is that? 5 lambda. 5 lambda is the separation between any well and any diffusion. Is it clear? That means here 3, here 3. Totally 6 rules till now you have seen. Okay, now you can observe other rules. Yeah, this figure you can observe with this figure. Yeah, this figure you can observe. Here you can observe very clearly. This is one more figure you have to talk about. Okay, if you are having a p mask and one more p mask, if you are having, what is the minimum separation between the two p masks? That is 2 lambda. Here one rule you have seen. Okay, that means the separation between p mask and p mask is 2 lambda. And similarly, the separation between mask and other diffusion or other polysilicon, whatever it may be, the separation between mask and diffusion, we can observe what? 2 lambda. This is 2 rules. That means totally 6 plus 2. Or how many rules? How many rules we have seen till now? 8 rules. Is it understood? Now I will write all these 8 rules. If you want, you may just observe. Okay, the separation between mask and contact area. What is that? Contact area? Absolutely 2 lambda. Then similarly, the separation between contact area and well. What is that? 3 lambda. Now similarly, the separation between mask and well. What is that? 1 lambda. Is it understood? Now you can observe that these are the 3. After that, when S is there, if you remember S, it is very easy to you. If 2 wells are there, if let us consider it is n well, what is the minimum separation between these two? 2 lambda. Why? Because they are same potential, either p well or n well. If let us consider one is n well, another one is p well, that means you are having a different potential. What is the minimum separation? 6 lambda. Okay, and one more thing, the separation between well and any diffusion. Okay, what is the minimum separation? Absolutely. What is that? 5 lambda. Okay, till now you didn't seen the figure 5. It is a unique one. You have to memorize it. Is it clear? After that, you can observe that this one, separation between two p mask. What is that? 2 lambda. And the separation between mask and diffusion. What is that? 2 lambda. Is it understood? And one more thing we have seen, wherever there is a p diffusion, it should be surrounded by what? P mask. Absolutely. It should be surrounded by what? P mask. That is very important point you have to talk about. Is it clear? Okay. Then that's it. These are the design rules completely. Okay, in the next class we will see how to design a layout, some step-by-step process. After that we can draw the layouts for different Boolean expressions using Cmos and Cmos logic. Is it clear? If you are having any queries, you may ask. Thank you very much. Have a nice day.